Hi there, welcome to ASA, which is part of Think Tank Online Learning. So in this video, I'm going to look on series and sequence. So first of all, I'm going to start by defining the word series and sequence, right? In mathematics, a series is an addition of infinitely many quantities, one after the other, right? As you can see, I have 1 plus 3 plus 5 plus 7 plus 9. So the next number that I'm going to have is going to be 11, okay? So this follow in order, a pattern. Then we have the definition of a sequence. It's a set of numbers following some pattern, right? So as you can see, our sequence, the sequence does not have addition, right? In series we're adding those sequence, right? So you can see we have 2, we have 4, we have 6, we have 8, and we're going to go to 12, 14, 16, and so on. So when you put an addition sign between the numbers, we're going to have series, right? Okay, so it can be positive or negative, right? So now we have some types of series. So in this case, we're going to look on what to call arithmetic sequence or arithmetic progression, right? So we have another type which we call geometric progression. Okay, so for now, what is an arithmetic sequence or arithmetic progression? So it's an ordered set of numbers that have common difference d between each consecutive term, right? So you have to take note of this because in most of the cases we're going to be mentioning the common difference, right? So that is represented by d. Okay, so as you can see, we have 2, we have 4, we have 6, we have 8, right? So now you can see from 2 to 4 we've jumped by 2, right? From 4 to 6 is 2 again, 6 to 8 is 2, 8 to 10 is 2, so the next number is going to be 12. So the common difference is not changing, right? So this pattern is going to continue, right? So the arithmetic sequence formula, so how to find the next term, right? You can see right now you can guess. So after 12 we're going to have 14, after 14 we're going to have 16. But what if someone asks you to find, let's say, the billionth term, right? You're not going just guess, right? So this is the formula that we have. So in the formula, as you can see, we have a n, right? We have a1, we have n, and we have d. So we're going to define each and every parameter right there. So a n is the nth term, right? So that is the term that we want to find, right? Let's say the 60th term, 70th term, 100th term, right? And a1 is the first term in the series or in the sequence, right? So from what we have right there, you can see it's 2, right? That is the first term, right? And what is n? N is the position, right? Like we said, is it second? If it's second, it's 2. If it's 100, we're going to put 100, right? And this is the common. Okay, so now let's look at this example. Okay, let's say I want to calculate the next 3 terms of the second. So we have 4, we have 7, we have 10, we have 13, and we have 16, right? And I can just guess, because if we say 7 minus 4, we're going to see there's a difference of 3 right there. So from 16, we're going to go to 19, but we're just guessing. So I want to use that formula to calculate those 3 terms, right? Okay, so I'm just going to write this question right here. Okay, so from here we're going to write a1, which is the first term of the sequence. So for the common difference, right, you can use, in this case I'm going to use the second term and the first term, right? If I say 4 minus 7, but you can even use in consecutive terms. For example, you can use a4 minus a3, a10 minus a9, right? So in this case, we're going to use 7 minus 4, and if we do that, we're going to find a difference of 3, right? And this one is constant. It must not change if we're in an arithmetic progression, right? Okay, so this one is the first term, we have the second term, we have the third term, we have the fourth term, we have the fifth term, right? So the next term is going to be the 60th. So we're going to find a 6, right? That's what I'm going to find, right? Okay, so now let's use our formula. We have our formula. So in this case, the term position is 6, right? Like what we said, to say n is the term position, so it's the 60th term. That's what I want to find, right? Okay, so now let's use our formula. So you say an equals to a1 plus n minus 1d. So on an, it's going to be a 6. A1, we have the first term. So the first term is 4. And n, we said it's 6 minus 1. And the common difference, we have calculated it and we said it's 3. So right there, you can see if we say 6 minus 5, we're going to get 5 times 3 is going to be 15. And now we can say 4 plus 15, and we're going to get 19, right? So we can now see that the 60th term is 19, okay? Like what we said before. And now let's go to the next term. It's going to be the 7th term, right? We know that. Okay, so I'm going to say a7, and a is the first term. It's 4, and n is 7 minus 1, and the common difference is 3, right? So I'm going to say 4 plus 7 minus 3, and 7 minus 3 and that is going to 7 minus 1 is going to give us 6, right? And we're going to say 6 times 3 is going to give us 18, right? And if we add 4 plus 18, we're going to get 22, right? You can see. And now let's find a8, right? That is going to be the last term, right? Because we're only going to find the next 3 terms of the sequence, right? So a8 is going to be 4, and it's going to be 8 minus 1, and common different is going to be 3, right? And if you do that, we're going to say 4 plus 21, and we're going to get 25, right? Want to find what is the sum of an arithmetic progression, right? Let's say I want to find the sum of 100 terms, the sum of 30 terms in a sequence, right? So we have a formula that we use. Okay, so this formula, you can see it's Sn equals n over 2 times 2a plus n minus 1 times d. Okay, a is the first term, n number of terms, and d still the common different, right? And we have another formula. So this one is Sn equals to n over 2 a plus l, right? Okay, so this one is the second formula. So it just depends on the examination board, but many boards allow you to have these formulas in your formula booklet or in a table, right? Okay, so this one, it includes last term, right? Instead of saying 2a plus n minus 1 times d, you can just say the first term plus the last term, and if you divide by number of terms and divide that by 2, we get the sum of the sequence, right? Or the sum of the series, right? Okay, so now we're going to look at a question, right? Okay, and this one is a past examination question. So the first term of an arithmetic progression is -1, and the seventh term is 35, right? That is the question. Okay, determine what you want to determine. So I want to determine the common difference of the sequence, and also want to determine the number of terms in the sequence. If the last term of the sequence is 437, the sum of the first 4 terms in a sequence, right? Okay, so first of all, what we do, we list what we're given. What is the given data? Okay, so we have a1, which is -1, right? You have to put the sign. And we have a7, which is 35. Okay, and we have our formulas. That's what we have. So now I want to solve this question. Okay, so using the formula an equals a1 plus n minus 1 times d, right? What we can do, we can now substitute the formula for the seventh term right here. Okay, so the reason why we didn't use a1 is because we're going to get n minus 1 and we're going to get 0 right there. So if we say 1 minus 1 and give us 0, we're not left with the d. So just want to make disagree with the formula in order to calculate it to find the value of d, right? So right here, if we use a7, right? You know, for a7, we're going to have a1, which is the first term. We have it, yes. And n, right? This term position is the seventh position minus 1 and d, right? And if we do this, we're going to have a very good equation, right? As you can see, this is what we have. So I'm going to say 7 minus 1 is going to give us 6, and we're going to move 1 to the other side, right? And if we do that, we're going to see that 36 is equal to 60. And now, if we divide both sides by 6, we're going to get our d as 6, right? Okay? And now, we have a common difference. Find the number of terms in the sequence if the last term of the sequence is 473. So this is the formula, and we have our last term, which is 473, right? Okay, so now, we know that the term, which is the last term, just say Tn, right? It's 473, but don't know the value of n. So by using that formula, you can say Tn is equals to a1 plus n minus 1 times d, right? So most of you may be confused. Why do we have Tn? We should have an. It's just the same. So Tn just means the term position, right? Same as an, right? So here we're going to have 473, and a is going to be -1 plus n minus 1 times 6. So the reason why you've put n, don't know what is the value of n, right? That's what we want to find, which is the position. Okay, so right there, we're going to add 1 on both sides, right? And we're going to have n minus 1 times 6, right? Okay, so we're going to have 474 is equals to n minus 1 times 6. And we're going to divide both sides by 6. That's what we're going to do. Okay, and if we divide both sides by 6, we're going to cancel right there. And 474 divided by 6 is going to give us 79, and right there we're going to have n minus 1. So now just left with adding 1 on both sides, and we're going to get our n as 80, right? So these are the number of terms in the sequence, right? And the last equation, the sum of the first 40 terms in this sequence, right? So we have 2 formulas. You can choose what you want, but I'm just going to use this one because it is the most used formula, right? So right here, n is going to be 40, right? So we're going to have 40 over 2 times what is a? -1, not forgetting the sign, plus 40 minus 1 times 6, right? And if we do that, we're going to simplify, and you have to be very careful. If you don't know how to simplify in an examination, just to good to use a calculator, and you should know the format, right? You should use the bracket so that your calculator will give you the good answer, the correct answer, right? Okay, so we're going to have 2 times -1 is going to give us -2, right? And right there, we're going to have 40 minus 1. First, solve what is inside the bracket. We're going to have 39. We're going to multiply that by 6, right? And as you can see, if we say -2, we're going to have 39 times 6 is going to give us 234, right? And now it's -2 plus 234, that is going to give us 232 times 20. And you can find our answer being 4640, right? Which is 4,640. That is the sum of the first 40 terms. We're going to look on another example, right? Okay, so consider a linear pattern 5, 7, and 9 going so on. Okay, determine T51. That is going to be the first question. Calculate the sum of the first 51 terms. That's going to be the second question. Okay, so this was set in November 2021. National Senior Certificate, right? This is South Africa. Okay, so here you have D1 is A2 minus A1. That's what we're going to use, right? To find the common difference, or you can say A3 minus A2. Just choose what you want. So I'm going to say 7 minus 5, and I'm going to find a common difference as 2. Okay, so to find T51, just going to use the formula. AN is equals to A1 plus N minus 1 times T. You can just put a TN right there. Doesn't matter, right? Okay, so I'm going to have A51 is 5 plus 51 minus 1 times 2. So N is the term position, which is 51 minus 1, and the common difference is 2. We're going to be left with 5 plus 100, because we're going to say 51 minus 1, that's going to give us 50 times 2 is going to give us 100. Now we can add 5 plus 100, and that's going to give us 105. Okay, now let's calculate the sum of the first 51 terms, right? So using our formula, Sn equals to n over 2 2a plus n minus 1 times d, right? So we're going to have 51 over 2, n being the position, right? The number of terms that we have, right? We're going to say 2 times a, the first term, which is 5. We're going to have 51 minus 1 times the common difference, which is 2. Okay, and now it's a matter of simplifying, starting with what is in brackets first. 51 minus 1, and we're going to multiply that by 2. And that one is going to give us 100 plus 1, so we're going to get 110 inside that bracket. So I'm going to say 51 over 2 times 110. And if we do that, we're going to get 51 times 55, right? And the final answer will be 2,805, right? Okay, so now let's look at this next question, right, from Zimbabwe. The sum of the 5th and the 10th terms of an arithmetic progression is 27. The third term is -9, right? Find the first term and the common difference. So this was ZIMSEC 2018 advanced level, right? Okay, so right here the question says the sum of the 5th term and the 10th term of an arithmetic progression is 27, and the third term is -9. Okay, so now we know that if we say T5 plus T1, we should get 27, right? If we add those two terms, right? That is going to be the first equation. And we have another equation. We know that T3 is equals to -9. That is the third term, right? Or A3 is -9. And above we could have said A5 plus A10 gives us 27, right? Still good. Okay, so I'm going to use this equation, right? So what is the formula for finding a term, right? We know that is a1 and n minus 1 times t, right? So for t5 we can agree that it's going to be a1 plus 5 minus 1 times t, and for t10 it's going to be a1 plus an n here is going to be 10, so it's going to be 10 minus 1 times t, right? And we have those two equations, right? So now we're going to use the fact that t5 plus t10 is equal to 27, right? So what is the formula for t5? We have it. What is the formula for t10? We have it. So I'm going to call this equation 1, right? So now it's a matter of simplifying. If we say a1, we're going to have 5 minus 1, and that's going to give us 4d, and we're going to have 10 minus 1, that's going to give us 9d, right? So here we're going to say a plus a, and if we do that, we're going to get 2a. 4d plus 9d is going to give us 13d is equal to 27. This one is going to be equation 1. So you have to be good at simultaneous equation before you start this topic, right? I should have mentioned that you have to be good at solving simultaneous equation, right? Okay, so t3 is -9. Do we have the formula for calculating t3? Yes, we have. T3 is going to be equal to a1 3 minus 1 times t, right? That is the formula that we have. And t3 we're going to put -9 equals to a1 plus 2d, right? So as you can see, we have our equations right there. We have equation 1 and equation 2. So now it's time to solve those two equations, right? So it's the question that we have. So you can choose the formula that you want, but in this case I would prefer substitution, right? So let's make a subject of the formula right there. So I'm going to have negative 9 minus negative 2d, right? I'm just going to move 2 to the other side, right? And after doing that, we're going to substitute the a in equation 2 into equation 1. So we're going to have 2, and for a it's going to be negative 9 minus 2d plus 13d is equal to 27. Now let's simplify. We're going to have negative 18 minus 4d plus 13d is equal to 27. So right there it's negative 4d plus 13, and you should be good in directed numbers. If you don't know, if you have a confusion in directed numbers, just check in the description below. I have a video explained how to solve directed numbers, how to solve problems including direct numbers in a simple way, right? So yeah, negative 4d plus 13d, okay, that is going to give us 9d, and we're going to have 18 plus 27 right there. We're also going to move 18 to the other side, and the sign is going to change, right? And we're going to have 9d is equals to 45. So divide both sides by 9, we're going to get our d as 5. That is going to be the common difference, right? Okay, so now I want to find the first term. So the first term is going to be a, right? So using equation number 2, right, we're going to substitute d in equation number 2, and we have negative 9 minus 2 times 5. And if you do that, we're going to have 2 times 5, and remember 2 is a negative, it's going to be negative 10. So negative 10, negative 9, we're going to add, and we're going to get 19, taking the sign of the bigger number, which is negative, right? So a1 is negative 19, right? So this was the question. Okay, so now let's move to another question. Okay, so 7xy and negative 11 is an arithmetic sequence. Determine the value of x and the value of y. Okay, so this was South African National Senior Certificate, right, 2020. Okay, so we have a 1 and we have a 2, we have a 3, and we have a 4. Okay, so we're going to use our general formula, right? So we know that a 2 is a variable, we don't know it, it's an unknown, right? That's why it's x. And a3, we don't know it, so we're going to use a4. So we're going to substitute the formula for a4, right? So an is going to be a4, a1, we have a1 right there, and n is going to be 4 minus 1 times d, right? a1, we have 7, right, plus 3d. Okay, so now what we're going to do, we're just going to subtract 7 on both sides, right? And if you do that, we're going to get negative 18 is equals to 3d. Divide both sides by 3, and we're going to get our answer is negative 6. So the common difference is negative 6. So the common difference can be either positive or negative, right? Don't have to worry right there. Okay, now that we have a common difference, it's now the time we find the value of x and y. Okay, so what is x? So x is on the second position, right? So I'm going to say on a2 it's going to be x, a it's 7 plus, we're going to have our d, so d is negative. So the reason why I have written d first, it is because it has a negative sign, right? So if I put negative 6 on the right hand side, it will look like we're subtracting 6 from what is inside the brackets, right? So here we're going to have negative 6 to minus 1 in the brackets, right? And we're going to have a 7 minus 6. What's going to be 2 minus 1? If I apply 1 times 6, I'm going to have negative 6. And don't confuse about the signs, right? Negative and a positive will give you a negative. So our x will be equal to 1. So now let's go to y, right? So an is equal to a1 plus n minus 1, right? So y is on third position, right? And a is going to be 7, d is still 6, n is going to be 3 minus 1, right? So a3 we know it's y. So we're going to have 7 minus 12. What's 3 minus 1? We're going to get 2. 2 times 6 is going to be 12, but 6 is negative, so it's going to be 7 minus 12, and we're going to get negative 5, right? But that is not the formula that we can use, right? We have many formulas to solve mathematics, right? So you choose the formula which is best for you and which is easy for you, but make sure you're using correct formulas, right? Also, in some cases you may obtain the correct answer by using the wrong formula, right? It always happens in mathematics, right? We can calculate the common difference by saying a2 minus a1, right? And you can say a3 minus a2, and you can also say a4 minus a3, right? These are the formula for common difference, right? So you can say that a2, which is the second term, x, a1, which is going to be equal to 7, and a3 is y minus x, which is the second term, right? And finally, negative 11, negative y. We know these three equations should be the same, right? So let's name this equation number 1, equation number 2, equation number 3, right? So if we solve these equations simultaneously, we can find the value of x and y, right? Okay, so here we choose what you call a reference equation, right? So I'm going to choose equation number 2 as reference equation, right? So I'm going to say equation 1 is equal to equation 2, equation 3 is equal to equation 2. After that, I'm going to obtain some new equations and I'm going to solve those equations simultaneously. So let's look on equation 1 equals to equation 2. So we have x minus 7, we should equate that to y minus x, and we can call this equation number 4, right? And if we just arrange, right, grouping left hands, right, we're going to move x to the other side and y to the other side, right? And we're going to put our constant 7 on the other side, right? So we're going to have negative x, we're going to have x minus y plus x, and that's going to give us 2x minus y is equals to 7, right? Okay, now let's look on question 3, which is negative 11, negative y, right? It should be equal to y minus x. Okay, so right here, moving y to the other side, right? So we're going to have negative 11, we're going to have y minus y, y minus x plus y. So it's going to be negative 11 is equals to 2y minus x, right? And this one is equation number 5. So now we're going to solve those equations simultaneously, right? So let's first write them. So now we're going to sub equation number 4 into equation number 5, but we already have y subject of the formula right there. So we're going to have negative 11, and the 2, instead of writing y, we're going to put 2x minus 7, right? And we're going to have negative x. So now it's a matter of simplifying. 2 times 2x is going to give us 4x. 2 times negative 7 is negative 14 minus x. And we're going to have negative 11. And we're going to add 14 on the other side. It's going to be plus 14 is equals to 3x. Okay? And we're going to have 3x is equals to 3x. So now it's time to divide both sides by 3. And if we do that, we're going to get our x as 1, right? Okay? So if we have our x as 1, now we're going to use equation number 4, right, to find the value of y. Okay, so I'm going to say 2 instead of writing s, or not writing 1, minus 7. So it's going to be 2 minus 7, and that will give us minus 5. So we still have the answer, right? But this one requires simultaneous equation, and the first one didn't require. So you choose what is good for you and what is best for you, right? Okay, so now we're going to look at what we call geometric progression. So the one we've been looking at is arithmetic progression, right? So now I'm going to go to geometric progression. So let's first start by defining what is geometric progression. So geometric progression, which is also known as GP, is a sequence where each term after the first is obtained by multiplying the preceding term by a constant r. Okay, so in arithmetic progression, the common difference was t, and in geometric progression, we now have what we call a common ratio r, right? Okay, so as you can see, we have a pattern here, which is 1, 2, 4, 8, 16, 32, 64, 128, and 256. Okay, so if you look at this sequence, you can see that it has a factors of 2 between each and every term, right? If you look at it. Okay, so in general, we write geometric sequence like this. We're going to have a, which is the first term, and we're going to have a times r, right? So like you see here, if we have 1, right? And the next term is going to be 1 times 2, which is the common ratio, right? So we're going to have a times r, right? But look, and on the next term we said 2 times 2, right? That means we've multiplied the common ratio twice, right? So the next term is going to be a times r times r. And the next one will be a times r times r times r, right? So that is the general sequence of a geometric progression, right? So it's going to be ar squared, ar to the power 4, ar to the power 5, to the power 6, to the power 7, to the power 8, to the power 9, going on like that. Okay? So the common ratio r is obtained by dividing the next term with the preceding term, right? Okay, that's how I obtain the common ratio, right? So we know that r is going to be tn divided by tn minus 1, right? Or tn plus 1 divided by tn, right? Say the 50th term divided by the 4th term, 60th term divided by the 50th term, right? Just like that, okay? but the common ratio can be equal to 0, right? You have to know that if you obtain the common ratio as 0, that means that one is going to be wrong. So now let's look at an example. So we have 1, we have 2, we have 4, we have 8, we have 16, 32, 128. Okay, so now to find the common ratio, we're going to say T2 divided by T1. You can say T5 divided by T4, choose what you want, but I'm going to say T2 divided by T1, and I'm going to say 2 divided by 1, and it's going to be 2, right? That's going to be the common ratio, right? So what is the nth term of a geometric progression? Okay, I can just guess the few terms right here, but if I ask you to find maybe the term on the 700th position, you're not going to find it, right? So we're going to use a formula. So the formula is going to be Tn, meaning the term position, is going to be A times R, which is the common ratio, times n to the power n minus 1. Okay, so we know A is the first term, n is the term position, and R is the common ratio. So this is the formula that we use, okay? And normally it will be provided on a formula booklet, right? But you just have to know it, okay? So now we're going to look at a question. So if R is 1 over 5 and A is 2000, determine Tn, right? The formula for finding the nth term, right? And also we're going to find T7, that is the term on the 7th position, and which term of the series we have a value of 16 over 15,625, right? That is 15,625. And that's a national certificate past exam question of November 2021. We have R, we have A, right? Now we have the formula, we have all the given details that we have. So I'm going to use our formula. So you know that Tn equals A R to the power n minus 1, right? So for A is going to be, we have our A is 2000 and R is 1 over 5 to the power n minus 1. So you have to make sure that 1 over 5 is to the power n minus 1, right? Okay, so this is the formula that we're going to use, right? So the reason why I've put a bracket right there is some people may simplify, right, saying 2000 divided by 5, and that is wrong. That thing is to the power of an unknown constant, right? So just leave it right there. Okay, so for T7 we have the formula, right? We've modified our formula, so now it's a matter of plugging in, right? So n is now 7, so I'm going to say 1 over 5 to the power 7 minus 1. So I'm going to have 200 times 1 over 5 to the power 6, right? So I'm going to first start by simplifying 1 over 5 to the power 6, right? So right here you can even just use the calculator and obtain the exact answer, okay? And make sure to not forget putting the brackets, right? So if I simplify 1 over 5 to the power 6, I'm going to have 0.00064, and now I'm going to finally multiply that by 200, and we're going to get 0.128. You can write it as a fraction if you want, right? It's now a matter of preferences, right? And on part C, which term of the series we have a value of 16 over 15,625. So we're going to say that on Tn we're going to have 16 over 15,625, but don't know the value of n. So using this equation, right, Tn is 2000 times 1 over 5 to the power n minus 1. On Tn we're going to put 16 over 15,625 is equals to 2000 times 1 over 5 n to the power negative 1, right? Okay, so now we can use indices or we can use laws of logarithms. So we're going to start by using laws of logarithms. Okay, so first of all, let's divide both sides by 200, right? Just to be left with that index term, right? Okay, so if we do that, we're going to have 16 over 15,625, right? And you can put this in brackets and then divide that by 200 so that your calculator won't misbehave, right? Or I won't give you the wrong one. Okay, so the next thing that we're going to do, we're going to take logs on both sides, right? So these are the natural logarithms, ln, right? You can just put log, right, if you want. Okay, so the reason why I'm doing this, I want to drop that power, right? So if we do this, we can drop n minus 1, right? Using the laws of logarithms, you have to know that, right? So now we have ln 0.00 something is equals to n minus 1 ln 1 over 5, right? So now we can simplify. We can simply divide both sides by ln 1 over 5, right? That's what I want to do, and make sure you include brackets, right? Especially on logs, right? Okay, and if we do that, I'm going to cancel right there. I'm going to see that ln 1 over 5 is going to be cancelled by ln 1 over 5. Okay, so now what we're going to do, now you just simply need to add 1 to the other side, right? That's what we need to do. And right here you have to take your calculator and make sure that 1 is not going to be divided by ln 1 over 5. And if you do that, we're going to get our answer as 10, right? So on the term, right, if said find the term position, you should just get a whole number, right? So this is 10, this is the correct, not like 7 over 5, 7 and a half, 7 what, right? Just make sure you're going to get a whole number. Like I said, you can, if you need index right here, right, you can just change this to the power of 5, right? Okay, so now we're going to look on the sum of a geometric progression, right? So we have two formulas, right? And all depends with the value of r, right? So the first formula is a 1 minus r to the power n over 1 minus r. Okay, so now this formula is valid when the value of r is less than 1, right? Okay, and we have another formula. So this one is a is equal to rn minus 1 over r minus 1, just the opposite of that. And this one is this when the value of r is greater than 1, right? Okay, so like always, let's look at examination question, right? So the first term of a geometric series is 14 and the sixth term is 448. Calculate the value of the constant r, that is the first question. Determine the number of consecutive terms that must be added to first 6 terms of the series in order to obtain a sum of 114,674. Okay, so we're going to find this one. So just don't worry about lengthy statements, right? Okay, just going to solve them. So what we're going to use, so we have the first term and we have the sixth term, and we're going to use our formula. We know that our formula Tn equals a r to the power a minus 1, right? Okay, so we say the sixth term is 448, right? That is the sixth term, that is the 60th term, right? So we're going to say 448 is going to be 14 r to the power 6 minus 1, right? So it's going to be 448, it's going to be 14 r to the power 5. I'm going to divide both sides by 14 so that we can be left with r to the power 5. And if we do that, I'm going to get 32 as r to the power 5. Okay, so you can use a calculator to find the fifth root of 32, or you can use laws of indices, right? Okay, so the fifth root of 32, that is going to be 2, right? Okay, now on the second question, determine the number of consecutive terms, right, that must be added to the first 6 terms of the series in order to obtain a sum of 11, 4, 6, 7, 4. Okay, so right here, this is the formula that we have. Okay, and we're going to use, since we're dealing with the sum, so this is the formula that we're going to use. And right here you can see that r is greater than 2, right? So this is, we're going to use the second formula, right? Now we're going to find the number of consecutive terms that must be added to the first 6 terms in order to obtain a sum of 11, 4, 6, 7. Okay, so let's find the sum of the 6 terms, right? First I want to find the sum of the 6 terms without adding something, right? So a is 14, right? The first term, r is 2, and n is 6 minus 1, right? I'm going to divide that by 2 minus 1, both r is 2. Okay, and now if you simplify, I'm going to get 882, right? Okay, so now I want to find how many terms to give us a sum of 114,674. So I'm going to use the formula again right here. Okay, but on the sum, we already have the sum, which is 114,674. You're going to have 14 times 2, but don't know how many terms, right? So it's going to be n, right? And we're going to have 2 minus 1. Okay, and if we do this, we're going to have 14 to the power 2n minus 1. Divide both sides by 14, right? And we're going to be left with 8191 is equal to 2n minus 1. Adding 1 on both sides, we're going to have 8192 is equal to 2n, right? Okay, and now we know that 8192 is 2 to the power 13. If we don't know that, we can use logs right here to drop the power, right? Okay, but if you know that 2 to the power 13 will give you 8192, you can just use the index. So now that we have same basis, just a matter of cancelling. So we know that n is equal to 13 terms, right? So how many terms must be added to the first 6 terms? So now it just is simple, because we're going to say 13 minus 6, and we're going to see that we're just going to add 7 terms, right? Okay, so to some of you that don't know how to use logs, okay, so just going to solve this question again. So let's say we have 8192, right, like what we have here. Okay, so now I want to use laws of logarithms. Okay, So let's put ln on both sides, right? So we're going to have ln h1 and 2 is equals to ln 2n, right? And if we do that, we're going to drop the power right there. We're going to have n ln 2 divided both sides by ln 2, right? And we're going to get our answer as 13 again, right? Use the calculator right here. So I've been calculating the sum of the terms that we know. So now I'm going to look to the sum to infinity of series, right? And geometric mean, right? Okay, so we have the definition of the sum of infinity of terms, which is the limit of sum of infinitely many terms in a second. So this is the formula that we use, right? And you should be aware that this is the symbol for infinite, right? Okay, so this is the formula that we use. We have a over 1 minus r. And some of you, those who may want the definition of these formulas, just check in the link below in the description. Okay, I have a full video for that, right, where we derive each and every formula that we use in series, right? Okay, but this one will be given on a formula booklet, okay, in some examination board, right? So the sum of infinite is going to be a over 1 minus r, a being the first term and r being the common ratio, right? And r cannot be equal to 1, because if r becomes 1, we're going to have 0 in the denominator, and this one will become undefined. Then we have an important thing that we call geometric mean. Okay, so we have a definition right here. The geometric mean between two quantities is equal to the square root of their product, right? Okay, so when three quantities are in geometric progression, so the mid one is what we call a geometric mean, right? So let's say we have a and b and c, right? So geometric mean will be equal to b over a and c over b, right? And now if you cross multiply, we're going to get b squared equals to ac, and making this a formula, we're going to get b as the square root of ac, right? Okay, so now let's look at a question, right? So given the geometric series x plus 90 plus 81, calculate the value of x and show that the sum of the first n terms is given by 100 by 1000 times 1 minus 0.9 to the power n, and the third part, hence or otherwise, calculate the sum to infinity. Okay, so you can see if you try to use a is equals to r to the power n minus 1, won't find the value of x, but good for us, we're given three terms. So the thing that we're going to do, so what we're going to do, we're going to use the geometric mean. So our national certificate, South Africa, November 2021. Okay, so right here our a is x, our b is 90, and c is 81. So now it's a matter of substituting, right? So I'm going to say 90 over x is equals to 81 over 90, right, using the formula above. Okay, so now let's cross multiply. So we're going to have 90 times 90, and we're going to have 81 times x. And if we say 90 times 90, we're going to get 81,000, and 81 times x, that will give us 81x, right? Divide both sides by 81, we're going to get our x is 100, right? So x is 100, and remember x is the first term right there. Okay, and now I want to show that the sum of n terms is given by 1000 brackets 1 minus 0.9 to the power n. Okay, so right here we have the first term. Okay, that's good, but when do you have r, the common ratio? Okay, so let's use what we have to find r. Okay, so you can use the third term or the second term, right? So right in, I just use these things, so I'm going to choose the second term, right? So the second term is 90, and first term is 100, and n will be equal to 2 since I've used the second term. So I'm going to have 2 minus 1, and if we do that, I'm just going to divide both sides by 100, right? And I'm going to be left with 90 over 100, and if we divide 90 over 100, we're going to get 0.9, and 2 minus 1 on top of r, that's going to give me r, right? And the answer is going to be 0.9. And now it's a matter of plugging that in my formula. Okay, so r is less than 1, right? So we're going to use this first formula of the sum of geometric series, right? Okay, so this is the formula that we're going to use. Okay, so now let's put this on a big page, right? Okay, so right here a is 100, 1 minus 0.9 to the power n divided by 1 minus 0.9. Okay, so 1 minus 0.9, that is going to give us 0.1, right? And if you say 100 divided by 0.1, you're going to get 1000 times 1 times 0.9 to the power n, and that one will be the final answer, right? And then or otherwise, calculate the sum to infinity. Now we're going to part C, right? Okay, so the sum to infinity, you know it. Okay, it's just a over 1 minus r. Okay, and a is 100 divided by 1 minus 0.9, and that is going to give us 1000. So that means if x was wrong, everything will be affected. So you just have to be very careful, right? Because if you get one thing wrong, everything will be affected. So these are geometric series and arithmetic series. Okay, so now we're going to go to what we call quadratic sequences. Okay, they are ordered sets of number that follow a rule based on the sequence n squared, right? So these are quadratic sequence. So as you can see, we have 1 and we have 4. So it's like we have 1 to the power 2, that is going to give us 1. And the next thing is going to be 2 to the power 2, is going to give us 4. And we're going to have 3 to the power 2, it's going to give us 9. Okay, like that. Okay, so quadratic sequence always include an n squared term, right? Okay, so in quadratic sequence we're going to have two differences, right? I'm just going to call them two common differences, right? Okay, so the first common difference is not equal, right? That means it varies, it is not constant, but the second one will remain the same, right? Okay, so let's just explain this using an example. Okay, so let's say we have 4, we have 7, we have 12, we have 19, and we have 28. So as you can see, from 4 to 7, we jumped by 3. Then from 7 to 12, we jumped by 5. Then from 12 to 19, we jumped by 7, right? Just going on, right? Okay, so right here, from 4 to 7, we said jumped by 4 minus 7, right? And from 7 to 12, it's 12 minus 7. And from 12 to 19, I'm going to say 19 minus 12, right? And finally, from 19 to 20, it's going to be 28 minus 19, right? Okay? So right there, it was by plus 3, plus 5, plus 7, and plus 9, right? So let's look at those differences, right? So from 3 to 5, we jumped by 2. From 5 to 7, we jumped by 2. From 7 to 9, we jumped by 2. Okay, so now you can see what I was trying to say. The first difference is different, right? It's changing, right? Because right here we have 3, right here we have 5, right here we have 7, right here we have 9, right? But on the second difference, you just see 2, right? 2 right here, 2 right here. Okay, and if you look right here, if we say 9 minus 7, it's going to be 2 again, right? So that's why I say the second difference will be equal to the same, will be the same, and the first one will fall, right? It will change. Okay, so let's go to another example. So this one, as you can see, it's all positive. So quadratic sequence maybe include negative numbers, right? So let's have 1, negative 4, negative 15, negative 32, negative 55 going on. Okay, so from 1 to 4, we're going to say negative 4 minus 1. We're going to say negative 15, and you have to take note of the sign of 4, it's negative. So we're going to say negative 15 minus the term, right? We're going to include this sign, right? So we're going to be negative 15, negative 4, right? And right, it's going to be negative 32 minus 15, negative 55 minus 32, right? And right here, we're going to have negative 5, and negative, we're going to have positive. So just have to not directed numbers, right? We can just use a calculator if they're allowed in examination, okay? So right there, we're going to have negative 5. Then we're going to have negative 15 plus 4. We're going to have negative 11. Negative 32 plus 15. We're going to have negative 17. Negative 5 plus 32 going to give us negative 23, right? Okay, and now that pattern, let's look at that pattern, right? From here to here. So we're going to say negative 11 minus 5. And right there, we're going to say negative 17 minus 11. And we're going to say negative 23 minus 17. Okay, so like I said, this one D1 and this one is D2. Okay, so now you can see you're going to have negative 6 right here, and negative 17 plus 11 is going to give us negative 6. Okay, so as you can see, this one are constants, right? That is the second difference. Okay, so these are the quadratic sequence. But what if you want to calculate the nth term? Because you can't just draw. Let's want to find the term on position number 60, right? You can't just draw 60 arrows, right? We have to use a formula, right? Okay, so from the term quadratic sequence, so what is a quadratic expression? What is a quadratic equation, right? So a quadratic is x squared plus bx plus c, right? That is what we call a quadratic equation, right? Okay, but in this case, we're not going to have x, we're going to have n, right? So we need our sequence to have this form. Okay, so for the nth term, this is what we have, right? want to find a formula in this form, right? Where A, B, and C satisfy the following equations. Okay, so these equations, have to take note of them, right? These are equations that we use. And most of the time, this won't be provided in a booklet, right? So 2A should be equal to D2. So D2 says it is the second difference, right? That is going to question number 1. Then 3A plus B should give you the second term minus the first term. A plus B plus C should give you the first term, right? Okay, so now let's look at an example, right? Okay, consider quadratic pattern. The first number is negative 145, negative 122, and third is negative 101. Okay, so write down the value of T4, that is the first equation. Show that the general term of the pattern is Tn equal to negative n squared plus 26n minus 70, between which two terms of the pattern will be the difference of negative 121. Okay, so this one is a National Senior Certificate South Africa, November 2021. So let's put this on a new page, right? Okay, so first of all, let's write our R. So from here, I'm going to have negative 122 minus 145, and this one will give us 23. Okay, then from 122 to 101, it's going to be a 3 minus a 2. That's going to be negative 101 minus 122, right? And that's going to give us 21, right? And now let's look at the difference between that. That one is going to be 2, right? So it's going to be 23 minus 21. That's going to give us negative 2, right? So you have to put the sign. So the next term right here, we know we're going to say this one is going to be constant, right? It's going to be negative 2, right? So we started with 23. Now we're going to go to 21. So the next term is going to be 21 minus 2, right? It's 21 plus minus 2, but it said plus and minus give us negative. And that one will give us positive 19. Okay? So now we're just going to add 19 to negative 101. And if we do that, we're going to get our answer is negative 101 plus 19, and that will give us negative 82. Okay? I'll put understand right there. Okay? Now, I want to find. Now, we're going to go to question number B. Show that the general term of this number pattern is Tn is equal to negative n squared plus 26n minus 70. From our question, I'm going to write question number 1. 2a is equals to D2, right? And take note that a is not the first term, right? It's different from the first term. It's the coefficient of n squared. So we're going to have 2a is going to negative 2, divide both sides by 2, and we're going to get our a is negative 1, right? Okay? And now, the second question, 3a plus b should give us the difference between the second term and the first term, and we have it right here. You can see it's 23 right there, right? Okay, so I'm going to say 3a and a is negative 1 plus b should give us negative 23, and right now we're going to say b is equals to 23 plus 3, both 3 is negative right here, and if we do that, we're going to get 26, right? Okay, lastly, we want to find c, so let's use the third equation. A plus b plus c should give us the first term, right, which is not a, so it's going to be negative 1 plus 26 plus c should give us negative 145. So c is going to be negative 145 minus 26 plus 1, and that one will give us negative 170. So now we have a, we have b, we have c. It's just time to write our formula, right? As you can see, like what the question requires us to do. Okay, now let's go to part C, right? So between which two terms of the pattern will be a difference of negative 121? Okay, between which two terms of the pattern will be there a difference of negative 121? Okay, so you just have to be careful and make sure that you understand your question. Okay, so we know this term can be either Tn and Tn minus 1, or Tn plus 1 minus Tn. So just choose what is good for you, right? So what I'm going to do, I'm just going to choose the easiest method to solve this question, right? Okay, so we know between some two consecutive terms, we don't know which term, but know that they're consecutive one after the another, right? So this one is Tn plus 1 and Tn. So let's write Tn. What is the formula for Tn? We have it from our quadratic formula, right? Negative n squared plus 26n minus 70, right? And for Tn plus 1, you have to take note right here. It's no longer n, it's now n plus 1. So I'm going to have negative. Instead of writing n, I'm going to add n plus 1. I'm going to square it. Plus 26n plus 1 minus 70. It should be good as substitution, right? okay? Because if you are good at substitution, simultaneous equation, this thing will be easy for you. So if we look right here, you can see we have tn plus 1 and tn and minus tn, right? So let's do that. Tn minus 1, let's substitute. We're going to substitute what we have right here. So this one is tn right here, and this one is tn plus 1, right? Okay, so now let's do that. So we're going to have tn plus 1 minus tn. So let's substitute what we have for tn plus 1 from here, right? And tn minus 1 from here, as you can see, it's right here. And this one right here, it's right here, okay? Okay, so should be good at substituting, right? All right, here, what are we going to write right here? Okay, we have an answer. Okay, what would that from the question is equal to negative 121. Okay, so let's put 121 right there. Okay, just like this. Okay, so now it's a matter of simplifying, right? So as you can see right here, I said minus times minus, right? That's why I have a positive right here. And I said minus times negative, that's why I have a negative right here. And finally, I said minus times minus, and that's why I have a positive right here. You have to take note of directed numbers, right? And right here is 26 times n, and I have 26n, 26 times 1, and I have negative, and I have positive 26, right? And finally minus 70. Okay, so now let's go. Okay, so this is what we're going to have, right? So right here we're going to have n squared plus 2 plus 1, right? Should be good at expanding. Okay, so those who don't know how to expand, okay, so I'm just going to use a short method right here. So what we say n times n, right? We're going to get n squared, and now we're going to say 2 right times n, right? And that's going to give us 2 times n, and finally we're going to say 1 squared, and that is going to give us 1. Okay, so that's why we have this. But you should know that I have excluded the negative sign. It's still affecting everything right here. Okay, we're going to simplify. So now let's simplify what is inside the bracket. Okay, so from here, look, we have n squared and n squared, but the sign of n squared, the first one is negative and that one is positive, so they will just balance each other and we'll get 0. And also you have positive 26n and negative 26n, the balance each other, will get 0. And we have negative 70 and positive 70, they'll balance each other and we get 0. And finally, so we're going to have negative 1, and we're going to have negative 2n minus 1 plus 26, right? So negative 1, if it right here, positive 26 right here, and 2n, which is right here, okay? So now let's simplify right here, subtracting negative 26 and adding 1 on the other side, right? So we're going to have negative 146 is equal to negative 2n. Divide both sides by negative 2, and if we do that, we're going to have for n as 73. So if n is 73, what is the next term? So the next term is going to be n plus 1, right? And that is going to be 74. So thank you for watching. Don't forget to subscribe.